Now let's look at a method to find horizontal asymptotes. Now it's a little bit different from finding the vertical ones, which are in a way quite a lot easier. Same thing as with our vertical ones, we generally get horizontal asymptotes in functions that have got fractions in them. But we've got a trick that we can use to help us find where they are. Divide every term, that's every term in both the top and the bottom of the fraction, by the highest power of x. Now power of x might be the x's, x squareds, x cubes. Now you don't need to include the coefficient, you just divide it by x, x squared, x cubed, whatever is the highest power of x in the denominator, not the numerator. So this is the really important part of this method. Look at the denominator, see what the highest power of x is and divide everything by that. So once we've done that, we can use the facts that we've already seen today, which is that as x becomes really, really big or really, really small, 1 over a massive number or a tiny number is virtually 0. So that tells us that we can use these to find the limit that the function is approaching, and that's the limit that y will be approaching as x becomes really, really big or really, really small. And the value that we get with this limit, that will be where our horizontal asymptote is. So let's do a couple of examples so you can see how it works. Here we've got y equals x minus 1 over x minus 4. So step 1 is, what's the highest power of x that I have in my denominator? X. So I'm going to divide everything, all 4 of these terms, by x to see what I get. So first step is to go ahead and do that, and just take your time and do it carefully. I've got x divided by x minus 1 divided by x over x divided by x minus 4 divided by x. Now the next step, we can just tidy this up. X over x is just 1. So if I rewrite this, I've got 1 minus 1 over x over 1 minus 4 over x. Now here I haven't really changed the function, I've just written it a different way so that I can use this fact in the next step. So in the next step, I want to think, alright, what happens when x is really big or x is really small? As x approaches infinity, what will happen here? Well, 1 is going to be 1, no matter what x is. It's 1 every single day of the week. It's a constant. So I'm going to say y is going to be 1 minus. Now, as x is massive or tiny, this 1 over x is going to be virtually 0, isn't it? So it's going to be 1 minus 0 on the top, and 1 minus, well, what's 4 divided by a huge, huge number? It's a fraction so tiny it's virtually 0 as well, and that would be 0 whether it's a really huge positive number or a huge negative number. So I can say here I've considered both plus or minus infinity, and either way, this part and this part are as good as 0. So what I've really got is 1 minus 0 over 1 minus 0. And that's the same as saying 1 over 1, which is of course just 1. So that's telling me that as x gets really large or really small, y is approaching 1. Now can it get there? No, because x can't ever be infinity, and it can't ever be negative infinity. It might get close, but it's never going to make it. That means y is never going to make it to y equals 1. And that tells me that as I go to graph this, I'm going to have an asymptote where y equals 1, because my function is never going to be able to reach that. Look for a part of the function that can't equal 0, and in this case, I've got x minus 4 can't be 0. So that tells me that x can't be 4. So I have my other asymptote over here going down this way. Let's find the horizontal asymptote on a graph like this. Now, we need to look at the denominator first and find what's the highest power of x we have, and the answer is x. So our first thing to do is just rewrite this, dividing everything through by x. So on the top, we've got x squared over x, and you might get to the stage where you can do this part in your head. As you're learning that, it makes sense to do it longhand just to make sure you don't make a mistake. Now on the next line, I'm going to tidy that up. X squared over x is just x. This I can leave like this. And on the bottom, I've got 1 minus 4 over x. So the next thing to do now is to think through what will happen as x approaches infinity. What will happen to y? Well, if we have infinity here on the top, we'll have to subtract 1 over infinity. Now, 1 over the massive number is virtually 0, isn't it? So we'll be subtracting 0. On the bottom, we'll have 1 minus, Now, as x approaches infinity, this whole thing approaches 0. It doesn't make any difference whether there's a 1 on the top or a 4 on the top. 4 divided by a number that's so massive is going to approach 0 just as it is when 1 is divided by a massive, massive number. So we get this, which is basically just infinity over 1, which is infinity. Now, what would have happened if x was approaching negative infinity? Well, we'd have negative infinity here, and we would be adding 0 instead of subtracting it, because this part would be a negative. So we'd be subtracting a very, very, very tiny negative that's as good as 0. So we'd be adding 0. Well, if you're adding or subtracting 0, same thing. And on the bottom we would have 1, and we'd be adding 0 again instead of subtracting it. So we can actually see here that as x approaches infinity, y approaches infinity, and as x approaches negative infinity, I haven't really needed to do all the work in here, I've thought it through. Oops, put an arrow. We approach negative infinity. Now what does all this mean? Well, if x can get as big as it likes, and y will keep on getting as big as it likes, and x can get as small as it likes, and y can also be as small as it likes, then there is no horizontal asymptote in this one. So that means that x can take any value that it likes. Now for a trickier example. Let's start in our hunt for a horizontal asymptote by dividing all 6 terms here by the highest power of x that's in the denominator, and that's x squared. So away we go, 3 over x squared minus 5x over x squared minus 4x squared over x squared, and the bottom will look quite similar. Now, tidying up, anything that's only got x's in it like this stays the same, but where I can do some cancelling, I can do so. Minus 4, that's just 4, over. Now here we've got 4 over x squared minus, we can cancel these, 5 over x again, minus 3. Alright, now we need to think, what's going to happen as x gets really, really large? Well, if you square an infinitely large number, it becomes even larger, and 3 divided by that massive number is as good as 0, isn't it? So y is going to approach 0 minus 0, because 5 over a massive number is virtually 0, minus 4. And on the bottom, we're going to have 0, minus 0, minus 3. So tidying that up, we've got negative 4 over negative 3, which is just 4/3. And that tells us that as x gets massive, y approaches this, okay? But it won't actually ever reach it. How do you know? Well, x will never reach infinity, so y will never reach this number. And so that tells us that there is a horizontal asymptote when y is 4/3. So make your mark here for 4/3, and we're going to have a horizontal asymptote. Then, of course, if you want to find the vertical asymptote, you look at the part of the function that can't be equal to 0 and have to solve that. And now you might be able to factorise that. If you can't, of course, you can always complete the square, or even easier, just use the formula. I would begin this one by making everything positive, multiply each term by -1, and I get this. And then you can solve it in a variety of ways to find where the vertical asymptotes will need to go.